The next form up is the p-series. And the p-series is one of the easiest series to recognize. I mean, literally, you got a variable down in the denominator. You just have to see what power it's taken to. If that power is greater than 1, this series is going to converge. And if it's less than or equal to 1, it's diverging. It's that easy. So we've got 4 examples up on the board right here. I'm going to ask you to take a minute and figure out what does P equal for each of these. Go ahead and pause if you'd like to try it. Some of these are a little mixed up, so I'll show you exactly what we're looking for. In this first one, that's to the 3rd power, P equals 3. In the next one, you'll see that whether we have the 6 on top of every single fraction, or whether we just multiply all the fractions by 6, it doesn't matter. That's a nice little constant. We'll just move that up front. And that means this is to the 3 halves. So guess what? P is equal to 3 halves. In the very next one, please don't be fooled by this. I don't want you to be fooled by this because this is really the same as 2 different series. The first series is a P series where P is 3, and the second one is a P series where P is equal to 1. And finally, we get to this last one over here on the right. Yeah, it doesn't matter what we take 1 to the power of, it's pretty much going to be 1. So that numerator is just 1. The denominator, however, is 1/2. P equals 1/2. So as we go down through, it's very easy to determine which of these 4 series would actually converge or diverge. Now the problem is, yeah, these 2 converge because they're greater than 1. This one is subtracting. Sure, the first one converges. But if you subtract something that eventually gets infinitely large, this whole thing is going to diverge. You're basically taking a number minus infinity. That's not going to work out so well. And finally, the last one over there, diverges. Now, it just so happens for any of those of you who like music, know musical instruments, or like the tonal quality of that. I've had several students who were very disappointed to find out that some of their math, even if they're a musician, is coming in college, and it talks about this. I don't even pretend to understand all this music theory, but basically for harmonic notes, the frequencies of everything, you start looking at them, you have 1, 1/2, 1/3, 1/4. Things are vibrating at just the right thing. It makes a nice harmonic sound, a harmonic chord. So I can't even pretend to give you all the background information on this, but I can tell you this is that thin edge, that breaking point. How do you know when something goes from being divergent to convergent? Believe it or not, this is that edge. Now this is going to diverge, and it looks like everything's getting smaller, right? According to the nth term test, this sequence is approaching 0. Unfortunately, if we want this series to converge, it's got to approach 0 a little faster. And here's the idea behind it. Theoretically, if you keep adding these numbers, the series will get larger and larger. But we know that it's going to go towards infinity because this number right here equals 1. The next 3 terms also equal at least 1. They actually equal a little bit more than that. The next, what is that? 8 terms equals close to 1. It turns out when you're using the harmonic series, I believe something like the next, somewhere around 15 or 20, but I'll say about 20 terms will add up to another 1. And theoretically, if you can keep finding clumps of numbers that add up to 1, if you keep adding 1 to a series, it will keep getting larger indefinitely. It takes more and more numbers to do it. It grows very slowly, but it never stops growing. It never stops growing in a way that the series diverges. If you have this to any other power greater than 1, these will continue to grow, but they will grow so small that the amount that you add on eventually will reach a limit. And you can find that. So that's the unique part of the p-series. Remember, for a p-series, first determine p, these 3 more examples. And once you know p, you know if it converges.